A friend of mine gave me this subwoofer unit. It's a Logitech Z 2300. It is a 2.1 system that is two satellite speakers and one subwoofer, but it came without the remote control, and the inputs, volume control, power switch, and all the stuff are in the remote. So in order to make it work without the remote control, we have to know what each of the 50 pins in the DB connectors in the back of the unit are for. For those of you who are here just to see the pin configuration, here you have it. For those of you that wants to know a little more about this subwoofer, the history goes that I was searching all over the internet for the pin configuration and applied all the configurations I found, but it's still not producing any sound. So I opened out the unit and found a broken coil, and I had to repair it, and also there was a problem with a shorted ground. Once I fixed all the issues, I tried the basic quick configuration test in this diagram, and it worked very fine. If you want to have the complete functionality of the remote, a very nice person took the time to disassemble his remote control and post the schematic, and turns out that there's a lot more than just 3 inputs and the power for the remote. There's also volume for the subwoofer, main volume for the wall unit, headphones, power indicator, and so on. For now, let me show you the basic configuration working on the subwoofer. Again, I had to disassemble everything in order to fix it, so let's hear it out. Oops. So here's the complete schematics, and as you can see, there is a website also, so you can pay a visit, and he also published the prints to make your own boards and the inventory of all the components to create your own remote control. From that schematic, we can see that the function of each of the 50 pins in the DB connector in the back of the unit are as follow. So pin number 1 is for the subwoofer input. Pin number 2 is not in use. Pin number 3 is the ground for all the audio signals, subwoofer left and right. And pin number 4 is the power ground. But I put a multimeter in here, and it is the same signal. Pin number 5 is for the standby switch. Pin number 6 is the right input. Pin 7, 8, 9, and 10 are not in use. Pin 11 is for the headphone jacks for the right channel. Pin 12, as you see it before, is the left input. Pin 13 is the left channel for the headphones. Pin 14 is not in use. And pin 15 is for the switch. It goes to pin number 5, and you turn on the unit. The unit has the main 120 volts AC in here. Then it goes to the fuse box, then to the main power switch. If you remember, we have a power switch in the DB connector, but it is more like to bring it out of the standby mode. From there, here are the connections that I made, and let me tell you that I make a huge mistake by making holes in the metal plate of the subwoofer. For some of you, this is very obvious why it was a mistake, but for the rest of the people, I will explain it later. We can see some operational amplifiers used to preamplify the subwoofer filter and also the signals to the main 4 amplifiers. But why there are 4 amplifiers? See, we only have 3-channel inputs, left, right, and subwoofer. Well, turns out that those 2 in the middle are in bridge mode. Each of the 4 are monolithic amplifiers, so they put 2 of them connected to produce the output power of the subwoofer. The 2 amplifiers in the middle are TDA 7295. Those are 80 watts each one if you provide them with plus minus 40 volts or 80 volts. With this unit, they do not provide the 40 volts. It only provides like 30 volts or 60 volts total. Here's the diagram for the bridge mode amplifier of those 2 to produce 160 watts. But again, that ain't gonna happen because we already know that the unit only provides 60 volts plus 30 and minus 30, and the amplifier needs 80 volts to produce those amounts of watts. For left and right channels, they are using the 7296 amplifier. Those are rated at 60 watts if you provide it with 35 volts or 70 volts total. Again, we are not. So I was thinking, those 2 have the very same pin configuration as the 7294 amplifier that use 80 volts. Well, it says 100 volts, but in fact it says that 80 volts below, and it provides 100 watts. So if we change all those amplifiers and replace them with the TDA 7294 and change the power supplies, of course, and also the filter capacitors, we can have a system with 100 watts per channel and 200 watts for the subwoofer. And as it happens, I have those TDA 94 from an old Bose subwoofer that I disassembled in a past video, and I have the power supply in there and all the capacitors and all the stuff, so I will just replace it, but that will be for another time. So I mentioned before that I make a huge mistake by modifying the backplate of the subwoofer. That is because the subwoofer has to move so much air that there's something called tuning for the subwoofers, because you need to tune the way the subwoofer moves the air in the vents, producing a distinctive sound. So opening additional holes in the back of the subwoofer made some horrible noises that are produced because of the high amount of air being pushed or forced through the very little holes. Many self-powered subwoofers has one compartment for the subwoofer box and another compartment for the amplifier, like you see in this video, in order to avoid those issues with the speakers, input, power connectors, and all the stuff. Logitech, in order to save some money, just put a lot of glue in the connectors. So when I made the holes for the new connectors, I got into a lot of trouble trying to eliminate those under several horrible sounds. Well, that's wrap it up for this video. Thank you very much for watching my videos, and I will leave you with the links and also this little video about an experiment I make for my Sequoia. I was trying to add a little bit more bass to the sound in the Sequoia. So I put all these subwoofers, but at the end I had to remove them. Someone made me remove them because it was taking too much space. So thank you very much again for watching my videos, and take care.